to the webinar today. I'd like to remind everyone that we are recording this webinar. Recordings will be posted on YouTube within about 24 hours of the close of this webinar today. If you have any questions today, please remember to type those into the chat. My colleague Brian Bates, our Director of Professional Learning, will be helping monitor the chat today. When you do type in a question in the chat, make sure that the drop down reads everyone so that we can all read your question and benefit from your the answers to those as well. For those of you attending in person, or I should say, those of you attending live today, you will receive PD credit. Again, evals will be mailed within 24 hours of the close of this event today, and you'll need to complete and submit that eval in order to receive that PD credit evidence of completion form. Today we are joined by Dan Mostyn, and Dan is going to be showing us how to teach and apply the STEM design process using build challenges and how he uses that in his classroom. So Dan, welcome today. I'm going to stop sharing and turn everything over to you.
All right, well, welcome everybody. I'm gonna go ahead and share my screen now and let's see if I can get it on there. And there we go. So as Matt said, today's webinar is about teaching the STEM design process using what I call build challenges. Just to get us kind of set here, this is how our hour is going to go. We're going to try our best to achieve the following objectives. So here's our goals. So I'd like to kind of teach you about the STEM design process and how designers and students use it to solve problems. We're going to apply this process to actually solve a few challenges during the webinar. We're going to use this process to think about lessons or activities for students that we possibly have as our own, or maybe we support teachers who have these students. How can we use that STEM design process in lessons and activities? And then I have some resources that you can walk away with for your use in whatever you do in education, whether that's teaching, supporting, coaching, that sort of thing. Our agenda today, so I'm going to introduce myself in a second, and I will have a chance for the folks who are here live to also introduce themselves. And then we'll get started right away with a build challenge. We'll go through some of the specifics of what the STEM design process is, some experience that I have with it, tips, ways that perhaps you can modify for your own situation or your own students. We'll do one more build challenge, and then I'll give you the resources you need to plan your own or to help teachers that you coach possibly or work with to plan their own build challenges with your own students. So before I introduce myself, this is an interactive webinar. So there is some material that you need. And we had it on the description for the webinar, but I figured if you're in an office or a classroom or at home, hopefully you have this stuff somewhere in your place that you're at. So I'm going to ask you this. If you had about 10 sheets, it doesn't have to be exactly 10 sheets. If you have 6, 7, 8 sheets of paper, 10 sheets of paper would be great. It doesn't have to be perfectly blank paper. It could be junk mail that you got, or, you know, old copies or something like that from your recycle pile. Some tape would be real helpful today. If you have Scotch tape, that's great, but I don't care if you have painter's tape or duct tape, whatever. So some sort of tape would be good. And then a pair of scissors is not required, but it'd be nice to have. You could always use the tried and true fold back and forth and rip method if you'd like. If you are watching this recording from home, then you could pause and maybe go grab this stuff if you'd like to. So I'm going to introduce myself, and if you need to grab some of this material while I'm introducing myself, that would be fine. And then we'll have a chance to kind of share who the folks that are on the call today can introduce themselves as well. So as Matt mentioned, my name is Dan Mostyn. I used to be a civil engineer, and now I'm a high school teacher. I've been teaching for, let's see, this is my 11th year teaching. Right now I'm teaching at Lockport Township High School. I teach in the CTE department, so career and technical education. I've taught CTE and science classes like all over the place. So we'll find out in a second who's on the call and where they're from, but I've been in urban settings, suburban, public and private schools. I have coached soccer and robotics teams in the past. I currently teach a STEM survey class where we do a little bit of kind of a little bit of everything, some technology, engineering, and also I teach an intro to autos class this year too, which has been exciting. And I just was kind of thinking about sort of why am I teaching? What drives me to do it when it gets tough? Because we know, teaching can be tough whether we're in a pandemic or not. And I try to use the fact that I know that I can inspire young people to find things that they're interested in, things that that maybe someday they'll have a career in. Maybe I could be a small part in sort of lighting that fire. And so that's what drives me to teach and to get up every day and to plan and try to do things like this too, to kind of share what I've learned. So what we're going to start with is a little bit of a build challenge. So we're going to look here at the rules of our challenge that we're about to start. So the first challenge here is going to be to make a paper diving board. So the goal is to try to make the longest paper diving board that you can, only using 2 sheets of paper. Okay, you could do anything you want to the paper. We're going to try to make the longest in terms of like longest sticking off the side of your desk or table or wherever you're at right now. And we're going to say that you may use tape, but only to tape the paper to the table. All right. So, and if you don't have tape, that's not a big deal. You can kind of hold the piece of paper with your finger if you needed to. All right. So we're going to take 4 minutes to complete this challenge. I'll have a little timer and I'll let you know what's going on with it. And also, if possible, and I know this might not be possible for some of you, but if it's possible to sort of turn your laptop towards your work area, it would be kind of cool to be able to see each other's work as it's happening. So I don't know, are you guys ready to go? Maybe we could use the chat real quick or to say if you all are ready. And then in a second, I'm going to start the timer and we're going to do this challenge. So let me get out of here for a second. Go back. I have a little timer set up right now. And if it's possible to show your build right now, great. If not, then maybe we could show it at the end, and I'm going to go ahead and hit the start button. You have 4 minutes starting now to go ahead and build your paper diving board. Good luck. All right, so that's time. Since we can't actually show each other what we did, then maybe we can describe sort of the experience over the last 4 minutes, what was happening behind those black screens. So let's start with Matt. Matt, would you be able to share sort of maybe what happened, how long your bridge was, what does it sort of look like, and your experience with this build challenge?
Sure. Yeah, it was, I tried to fold the paper hot dog style multiple times over into where I got to about like a 2-inch strip. And then I weaved the two of those together. So yeah, I fold each paper the same way. And then I basically put them together, and then I pulled them out until, I don't know, I guess it's the best way I could say is like the friction of them didn't let the other paper fall out. So I don't know if you'd I didn't have tape, so I'm saying my palm holding on it, maybe it's 20 inches off the edge of the table.
Pretty good. I think that's pretty good. All right, nice. Thanks, Matt.
Mm-hmm.
Alicia, you want to let us know how yours went?
Sure. So I kind of did something similar. I just folded each piece of paper into quarters vertically, and then I just kind of tucked one piece of paper into the other, almost like a taco or a hot dog too. But I just was able to get the length of the 11-inch piece of paper. So, but it stuck out pretty far because it was like rigid enough, from the two pieces of paper that were folded a few times together. So I'd say maybe like 10 inches or so.
All right, great. We had the hot dog reference twice so far, so that's good. I like that. Or wait, we had taco and then hot dog. Let's see what sort of, maybe Angela has a different food reference she could use for hers. How did yours go, Angela?
There's a disaster here. So I did do the same thing. I used it. I folded the paper in quarters, and then I just couldn't seem to get any further than that. So I'm visual, so I'm really interested in seeing how to make this work.
All right. Okay. Well, this was a kind of a good warm up, I think, for us, and just to kind of get I know we're doing. I had classes all day, and I'm sure you all had meetings and meeting with teachers, students. So it's a nice way to sort of kind of get us going, thinking about design and building, and then how to sort of relate this to our classes. So we'll take this first build challenge. There will be one more. So, if you do have some of that scrap paper laying around, we will use it a little bit later. All right. So I'm going to go into a little bit of sort of, I guess, theory right now, and just sort of my experience with teaching STEM and design specifically over the next few minutes. If you have questions, Matt is actually looking at the chat, and he's going to interrupt me if there's a question that pops up that I could maybe answer. So that's how we're going to handle any questions or any even comments that you have. There's only 4 of us kind of participating today, so I do want this to kind of be a back and forth. And I know, Matt, you had not Matt. Oh yeah, we have 2 Matts here, Matt Jacobson and Matt Sly, our participant. You've taught STEM before, so if you have anything to add from your experience, please, by all means, throw that experience in the chat, and then we can get yourself unmuted and you can add to this conversation, because I'm sure you have stuff to add from your perspective as well. So when we talk about STEM and design, we're talking about, of course, science, technology, engineering, math, right? The way I like to look at those disciplines is that there are different goals for each discipline. They're related to each other, but each discipline has a different goal. And sometimes within those disciplines, something needs to be created to achieve those goals. So we have this process, some people call it the design process, right? We use this process to design new things to achieve goals in science, in tech, in engineering, and in math. Some of the kind of end goals that these professions have, and this is sort of how I talk to my students about this. And I have high school students, but I think you could bend this to any sort of level of students. Talk about, well, what is science? Scientists, their goal is to learn new things through experiments. Engineers, their goal is to solve problems. People in technology, and I know I'm generalizing here, but this is sort of kind of a way to introduce STEM to a lot of students kind of in a quick way. People in tech learn how to and apply skills to build things or systems that will work properly and safely. And an example for mathematicians, sometimes their goals have to do with new algorithms in terms with research, or programs and coding, I think kind of fit in with that math. So when we teach a STEM class, for example, that's what I do. I kind of dip into all 4 of these goals from time to time, depending on the unit that I'm in. I have a unit that's more engineering and tech based. Right now I'm starting a robotics unit. So it's more, I would say, math and engineering based in terms of coding and probably technology as well. Coding and figuring out solutions to challenges that I throw at them. At any rate, if you're teaching STEM, you're designing things, whether you're in science, engineering, tech, or math. So how do we set up our students for success with the design process? I'm going to tell you a little bit about how I do that and what process I use. And then we're going to try to apply it on a second build challenge. That's how the rest of today is going to go. So as I'm sure you guys probably know, there are lots of design processes that are out there, right? If you Google design process or engineering design process or STEM design process, there are thousands of them. You know, every company that is an engineering or design company has their own process that they have for their employees. I have used a bunch of them. I found one that I like a lot, and it's from actually a museum in Minnesota. So it's called the Works Museum. This museum is geared mostly for elementary students, but they have a bunch of resources online. Let me go back for a second. I'm going to click on a few of these resources just to show you their website. They have some of they talk about some of the Minnesota standards. They have the design process that I'm going to talk about is actually right here. There are resource guides for teachers. There's a lot of stuff in here. They have their own professional development that you can take a look at. They also have a focus on women in engineering. So they have some posters and activities that you can download in different languages for your students, or maybe teachers that you work with can use this stuff. But what I found was most valuable from their website was their design process that they've published on their website. So this is the design process that they have on their website, right? So I really like this process a lot. It's simple. It's 1, 2, 3, 4, 5, 6 steps. It has a flow to it that we'll talk about. But I know that there are teachers that maybe have heard of STEM, want to do STEM. Maybe they don't have STEM specifically in their curriculum, but they have a science class that they teach or something like that. And they're not sure kind of how to get at it. Do I want kids to build stuff with spaghetti and marshmallows? Why would I want to do that? What is the benefit of using maybe a process in order to design in STEM? The things that I've found by using a process like this is it gives structure to design work that students do. So it gives them sort of a map of how to design things. And it gives teachers almost a structure as well to be able to guide students through the process of designing. When you have students in groups, it's easier to kind of facilitate that group work if you have a structure like this. There are points for reflection and opportunities for writing and kind of inner monologue and kind of talking and reflecting about design. As I'm hopefully you are seeing today, it is low budget friendly. I've worked in all different kinds of schools where I've had large budgets, small budgets. You can do this on a shoestring budget. You could do this if you have lots of money to spend. I've had teams and clubs that have used this process to design things, but if you have a maker space, this is something that you can use to help guide students. And I think even though this is sort of published on a museum's website for younger students, I'm thinking middle school to junior high, I think this design process could be used at a professional level. I really do. It's simple and it's elegant. That's what I like about it. And as I'm saying in the last bullet point here, it prepares students for future careers. So as someone who's been in the field before, I've seen this. I've seen different versions of this, and this is a very clear version, something that I think students can actually use in careers in the future. Or at least be aware of it so that they could apply the baseline knowledge that's here to maybe a more elegant and maybe a more complicated version of it if they go to college or go, work at Boeing or something like that. So I just have in my slides, I'm not going to spend a ton of time on this, but I have some of the stuff that I ask my students I show my students when I go through this process. We start off with thinking about what are the rules, what are you limited by, what is the challenge, identify the problem. After that, we go into more of a research step, but we know that research is a word that turns a lot of people off. So exploration is maybe a more positive way to spin this. You can play around with materials, you get ready for the brainstorming that's about to happen. Then you do that brainstorming, you come up with as many ideas as you can, you pick a concept to run with. At this point, you would be drawing. Drawing is a great way to design before you actually build your design. And stressing a positive attitude during this process, you know, that we're encouraging each other, because we're usually working in groups when we do this sort of work. Then you take that research, exploration, and drawing and brainstorming, and you put it into your idea, your concept that you're going to go with, and you build your idea. You test it out. After you build it, I like to have my students make a plan for testing and whatever, and record some sort of data. That could be numbers, it could be anecdotal data, it could be a video, pictures, and to do a few trials perhaps of testing out your design. And then finally, we try to make it better. We think about our design, we reflect on it, we look at the test data, and if we're happy with our design, we can stop the process. But honestly, most of the time we go ahead and we try to improve it and redesign. So I added, so this is the Mostyn addition to the Works Museum design process. I think I should give them a call. I haven't done this yet, but give them a call and tell them to kind of maybe put a little, a circular arrow in. I guess they have it right here, but I like to tell my students that this is where you loop. You loop and you loop and you loop between design, create, try it, make it better. Design, create, try it out, make it better. You keep doing this until the time runs out, because that's how engineers and folks that are in design, science, technology, mathematicians, they want to spend as much time getting their design perfect as can be until they run out of time or money, right? That's kind of in the real world where we see this. So I want to give you a few tips for implementing something like this, whether it's in a makerspace, whether it's in a classroom, whether you're coaching a teacher on how to do this sort of thing in their classroom. Try it out as a quick, hey, this is what a designer is. This is STEM design. These are my tips that I've learned over the last, probably 7 years or so of teaching engineering and STEM that I've learned about the design process. And then after this, we're going to go ahead and do our second build challenge. So that way we can kind of keep this from me talking the whole time and you actually trying out a little more building in a bit. So these are my tips. If you're going to do this for a larger design, maybe you have like a grant or something and you want your students to make a garden out in your class, next to the playground. I would make sure before you try this with a big design that you practice with low stake designs, like with paper or with clay or with Legos. Give them challenges for building or making something using low tech, low cost equipment that they can practice this this process with before going more complicated. Like maybe if you have a robotics team or you have a bridge building contest, or you do 3D modeling on using Onshape or Tinkercad or something like that. Practice with low stakes first. I always like to start with smaller groups before going to bigger groups. So I like to, if I'm teaching my students how to design over the course of a semester or a year, I always start with groups of 2. And then I do groups of 2 for a few times, and then I add a third person in. I would never do teach this with a group of 6 or 7 or 8 people right away. It's just too many moving parts, and the students have to get used to that there is a process for design. Especially if you have a club or a team that's using the design process, you definitely want to split them up into smaller groups first before a larger one. This is a big one, and this takes practice, and I'm sure that like Matt Sly, I'm sure you could probably attest this as a STEM teacher. Be ready to mediate minor conflicts within groups. So there will be disagreements, and students sometimes have to see how those disagreements can be worked out, because they might not have people at home or friends that are good at mediating minor conflict. So be a model for the group as you go to them and you hear what the problem is, and to help them learn how to compromise minor conflict. All right, these are 4 ideas that I want you to keep keep your ears open for, because you want to kind of squash these sort of ideas or this sort of culture, I guess, if it pops up. So you don't want people to think, oh, I don't ever read the instructions, so I don't need a silly process for design. We have to kind of show students how this process can be meaningful and beneficial. My group members' ideas are never going to work. I'm just going to go with mine. A lot of times you don't hear this, but you see it. You see two or three people in a group and one person doing their own thing. You want to try to jump in there right away to make sure we can change that mindset. I'm going to design this without the rest of my group. They can just make their own. So similar as what I said before, many students would rather work alone because they can control their own work. It's harder to work with other people. Let's try to finish this as fast as possible and be the first ones finished. That's another thing. You want to leave enough time where students can actually focus on the design, reflect, test it out. We don't want them to be too hurried unless you're doing a professional development and you want to do quick ones like we're doing today. And then I think I had one more here. Yep. Consider, if you have a bigger design, setting each step as a checkpoint to allow for the teacher to have formative assessment. It also can encourage the students to slow down and appreciate kind of like what each step of the process means. So what I've done before is I've actually have each step of the design process as a separate assignment or a separate part of a packet maybe. And it helps to split it up so students know that designing and building something isn't one just big step where they jump in and do it right away. So those are my tips and advice that I've encountered and learned over the years. What we're going to do in a second is we're going to have a second build challenge. So the second build challenge is also with paper. You may use more paper with this one. And if you did have tape, it's going to be coming in helpful. But if not, I'm sure there's something that you could think of to think outside of the box here. So here's your second build challenge. And we're going to do this one a little differently. Last time when we did the paper diving board, we didn't actually use the design process. This time we're going to use the design process, and it's going to take a little longer, and that's okay. All right. So here's what we're going to do. We're going to try to build a paper tower this time. You may use up to 6 sheets of paper, and it must be self-supporting. So it's got to support itself. You can use tape anywhere on the design, but it can't lean into anything. All right. Now, I have here that we have 8 minutes to complete this challenge. What I'm going to do is I'm actually going to give you 4 minutes. And in those 4 minutes, I want you to do the first 3 steps that are over here on the side. All right. So what I want you to do here is I want you to reflect on the rules we just went over. I want you to write down at least 5 concepts. Those are like little ideas that you might have, all right, that might work. They don't need to be the whole idea, just little things that might work. Because Matt Sly, you said you don't have tape, so some of your concepts might be how you're going to connect pieces of paper. And then before you build, we're going to draw a sketch, okay? So right now, I'm going to start my timer for 4 minutes. And for the next 4 minutes, I want you to reflect on these rules. Look at them again if you need to. I want you to write down at least 5 things that you could do with your tower. They could be little ideas, big ideas, somewhere in the middle. And then I want you to draw a sketch. And you're not allowed to build until I say go. All right. So I'm going to put the timer on over here. Well, I'll just kind of look at the timer from time to time. There's about 3.5 minutes left. And we're just doing the following things. We're reflecting on the rules. We're looking at those rules. We're writing down 5 concepts on a piece of paper, 5 ideas that could go with our design. And then we're going to draw a sketch of what we are going to do. All right, so I'm going to mute right now for a little bit, let you guys get to work. And then I'll be back when the timer runs out. All right. I'm actually going to cut the prep time short here. I'm going to reset the clock to 4 minutes, and I'm going to start it. You may start building now. You have 4 minutes to build your tower. Sometimes when students start building, they have a plan. They have their sketch nearby. They have their concepts they've written down, their ideas that they think they might use. And then sometimes it kind of goes out the window, and that's okay. I like to tell my students to have a plan going into it, try to follow it, and then sometimes it works, sometimes it doesn't. But at least we have a plan going into it, right? And we kind of change that plan as we cycle through the design process, cycle through those last couple steps.
Can I ask a question?
Absolutely.
When you have students do a times just like design, writing things down or jotting down ideas or drawing ideas, do you feel like you often need to make them have a minimum number of ideas? Because I feel like sometimes kids have one, maybe two ideas, where it's like you want them to get in the habit of generating like as many as they can think of. So do you ever do like a limit or like a minimum number?
I do. And usually what I do is I'll make that number kind of like a larger number than they ever think they could do. And I have to teach them how to brainstorm. So a lot of students also, they're not sure how to brainstorm. And what I like to, there's I don't know what this would be. I say like brainstorming is kind of like cooking. If you cooked like a pound of spaghetti noodles, like you take a package of spaghetti noodles, you cook them, you boil them, you drain the water out, and then you take that big giant lump of spaghetti and you throw it against the wall. How many noodles are going to stick to the wall? And they say, oh, I don't know, maybe 3 or 4. And I'm like, well, that's kind of what brainstorming is. You got to come up with as many ideas as you can. Don't limit yourself. Don't worry if it's a good idea or a bad idea. And you might have, out of 100 ideas, you might have 2 or 3 that stick. And so that is a lesson that I will do early on in a STEM sort of class. And then once they practice it, then they realize that it's okay to have like an idea that's not perfect. Then they get a little more comfortable getting ideas out. So that's one kind of things that I tell my students. Also, it's really important to have a positive attitude while you're brainstorming. You can't have anybody saying, oh, that's a bad idea. And I tell my students this: what would happen if one of your teammates said, oh, that's kind of a bad idea? What would happen? How would you feel? And often the students will right away will say, oh, then I don't think that person is going to actually share any more ideas. And I said, that's the problem. We need to have as many ideas as we can. Quantity over quality.
Thank you. That's great.
I recently had a project where I had a cookie cutter. We've designed cookie cutters for the baking students. And it was interesting because the STEM students had to sort of teach the baking students how to brainstorm. And that was something next year when we try this, and we might do maybe the brainstorming lesson. We'll do it with both groups of them before we try it as a larger group. We have this process here that we just kind of use to design something and build it. And let's see how our participants did. So Angela, why don't you go first this time? Because I think last time you shared out last. How did this process go for you? And what does your tower look like?
I made a stackable tower. So I rolled 2 pieces of paper, and then I laid one flat, a half sheet on top. And then I rolled 2 more.
Oh, I like that.
It on top. It's kind of wobbling. I don't know if it's going to take that half sheet on top. So I just thought that I would use the rolled paper as a base and then build from there.
That's great. That's thinking outside the box. That's excellent.
Yeah.
I was in my head, the first thing I thought of was a teepee or something. And that's like, I like how you were sort of thinking outside the box there. Can I ask you a question, Angela?
Yes.
I have a few questions on here that maybe you could kind of reflect a little bit on how this build challenge felt maybe different than the first one, since we sort of had those first few steps that we went through where we wrote some ideas down and we sort of drew a little bit, sketched a little bit. And do you think it was worth it? Do you think it would be easier to build something like this if you just winged it?
I think the process, it actually helped because I am visual. So kind of thinking through planning, so designing, And then, giving that wait time to kind of digest a little bit, will it work? What may I need to take a second look at? Will it wobble? Will the paper actually support whatever is placed on top? So I think going through the process, it helped out tremendously. Whereas before, it was just, okay, I want you to create this, go for it. Thinking through at the same time, it's just too much.
Okay, great. Well, thank you for those reflections, and I appreciate you sharing out like that. Matt, and you're a STEM teacher, and I would guess that you might have a process that you use. Would you mind just sharing what happened with your tower, and then maybe if you could reflect on your own experience using the design process today, or as a teacher, or maybe what does it look like in your classroom? That would be really helpful, I think.
Oh yeah, sure. If I forget something, feel free to ask a probing question because I might forget all those. But yeah, I think one, I have pre-pandemic, it was my first year so I used the design challenges as a big function part of my class. And so I used something very similar to this. And I like this design that you found here. But what I liked about the way we did it today was I like that breaking it up into 2 sections. I tried to use timers to help kids take a moment to reflect at the end, because I felt like that was something that kids just didn't naturally want to do. So I would use like a timer, like you had this long to get it, and then that way I made sure there was like a pause, cleanup, reflecting time at the end of things. So anyways, I guess that's how I use this I have used it in my class. I wanted to attend this to get back into just kind of reinvigorate myself with doing this in my class. For me in this challenge, I liked splitting it up and getting that kind of plan together before I got into the action. It would have been helpful to have some of the people here on the webinar in a group, because I was really maybe like you. I immediately thought triangles and folding and making kind of like a tower out of straight, just like making each paper into a beam without tape. It didn't work very well. But yeah, I like that idea of circles. That'd have been a good one, because I think I could have done that without tape. And so now I'm thinking about how you could do this challenge without tape for kids. So,
right, yeah. So, or you have them do it without tape one time, and then you let them use the tape next time, or you can kind of go back and forth with that too.
Yeah, constraints help make people creative, so that's good.
Absolutely, yeah. Well, that's great. And Matt, I don't know if you've noticed this as well, but just in terms of like the joy of learning and the joy of being in a STEM class, little build challenges like this from time to time, they not only help reinforce the process that you might have implemented on bigger projects, but little smaller ones like this can be really a lot of fun too. So that's something I've experienced in my classroom.
Yeah, I would just say I think it's a big one. In fact, I tried to apply this to do like what you said, like bridge design, real early on in my first year, back in the classroom, and it was a train wreck. Mainly because I just felt like it was so much waste. Like there was so much waste of supplies and time, and those are the supplies. I mean, I just felt guilty about the environmental waste of how much glue I was throwing away. But I mean, I needed the kids to go through the process. They didn't need to go through something expensive and make something big out of it. And so it allows for iteration. If your supplies are cheap, you can do multiple things.
Absolutely. Well, great. Well, thanks, Matt. Thanks for sharing all your expertise on this as well. And I don't have a lot left here. I do have I have a slide here. Oh, this is not looking. Let's see. I got to get you guys out of the way here. I have this last slide because, when I want to do a build challenge like this, and I just kind of want to practice with my students, I do a lot of Googling and I try to find what other people have done. I found this one. It's really good. These are kind of a little more complicated, I guess, build challenges. They have a lot of materials associated with them and a lot of rules, but that's actually okay. It's an Iowa organization for creativity, I guess. And you'll get a copy of this slideshow at the end of this. You can click on any of these, and it actually has. I just clicked on a random one. These are all like build challenges that you can do. They have everything here. They have the procedure, timing, setup. They even have like diagrams sometimes or handout. Yeah, here's a diagram right here. Or handouts for the students and scoring. You could get really creative, or there's a lot here. I usually take something like this and pare it back a little bit, make it a little more simple. But these are kind of places for me to brainstorm these sort of challenges as I'm trying to teach the design process. So feel free to use these or give them to teachers that might want to try some of this stuff and just realize, hey, you don't have to use all the materials. You can limit. And as Matt said earlier, limiting some of the materials actually can make students more creative in their brainstorming. So that's basically it. This is some resources you can take with you. I really just have a last slide that's open for questions or any general reflections that you have. And I just want to thank you for your time and participation. I know that sometimes you don't really quite know what you're getting into with PD, and today you had to build stuff. And so thank you for coming out of your comfort zone a little bit if that happened with you. And that's about it. If there is any questions or anything, I'm here to answer them. And I'm going to stop sharing now so that way, I don't know how to stop sharing. Maybe Matt, oh, here we go. There we go. So if there's anything that you have any questions for me or anything, I have a couple minutes here, and that's about all I have for you today.
Okay. Well, Alicia, I see you have your hand raised. Do you have a question?
I do. I just had another question. Do you have any suggestions for how you can help groups where maybe one student really never says anything, or one student is always the one that leads and is always the one that whose design is used? Like how you can balance it out and help kids like learn how to engage in a group if depending and like navigate their own personality.
Yeah. So what I would do if you had that situation is I probably would have roles for the students for each step. So for example, like if you were going to brainstorm, we talked about that earlier. You could have, maybe brainstorming is not a great step for this. Maybe you were trying to like draw sketches of what was going to happen, right? And maybe you had one person who was doing the drawing, and then other people were going to be the people that were going to contribute ideas. Or, what I would say is I would set up roles for the students and have some of those roles as more talking and leadership roles for, at each step of the process. So that's kind of what I would probably lean towards if you have that as the case. And then you would switch them up, right? You wouldn't want, and then next time you had a design process, you would switch those roles so that maybe somebody else was the leader of the group or whatever, something like that.
Cool. Thank you.
You're welcome.
Okay, we'll leave things open for just a moment here to see if there are any other questions. I have put a link to Dan's presentation slides in the chat. And for those of you who are watching this recording, you'll find the recording down below the video window in the more information box as well. So if there are any other questions, please feel free to type those in the chat, and we'll pause here to give you an opportunity to respond.
And if any questions pop up later, or if you're watching the recording, feel free to send me an email and I can try to help you brainstorm or answer any questions that you have.
And I have too many windows open here. Dan, your contact information is included on that slide deck?
It should be. I'll put it in the chat too.
Oh, that's okay. We'll check that slide deck to get in touch with Dan. I don't see any other questions, Dan, so I think at this point we'll wrap things up.